Hi, Assalamualaikum. We are going to present about the extract of the vanilla bean vanillin for subject CHM301 Organic Chemistry 2. Meet our group members Sharifah Alia Diana, Farah Wahida binti Sudin, Nurul Ain Ashikin binti Abdul Hafiz, and Farah Adiba binti Jamaluddin.
My name is Sharifah Alia and I'll be presenting on the introduction of vanillin. Vanillin, C8H8O3, is the key compound behind the sweet and creamy aroma of vanilla. Chemically classified as a phenolic aldehyde, it contains a benzene ring with hydroxyl OH, methoxy OCH3, and aldehyde CHO groups, which contribute to its unique scent and reactivity. Naturally found in Vanilla planifolia bean, vanillin is released during curing through the enzymatic breakdown of glucovanillin. Due to the high cost of natural production, synthetic methods such as guaiacol oxidation and lignin-based synthetic using paper industry byproducts are commonly used. Vanillin is highly valued for its solubility in organic solvent, making it ideal for use in food, flavoring, perfumery, and pharmaceuticals. It also acts as a precursor in the synthetic of drug, agrochemical, and biopolymer. Whether natural or synthetic, vanillin plays a crucial role in flavoring fragrance and industrial chemistry, showcasing its versatility and importance. Moving on to the next slide, which is structural compound. This is the structure of vanillin. So as you can see, on carbon number 1, there is double bond O, which means it has a homolog series aldehyde and the functional group is carbonyl. And on the third carbon, we have OCH3, which means the homolog series is ether and the functional group is alkoxide. And for the fourth carbon, we have OH, which is alcohol and attached to a benzene ring. So this means the homolog series for this bond is phenol and the functional group is hydroxyl. So as you can see, the structural compound IUPAC name is 4-hydroxy 3-methoxybenzaldehyde.
During the time of the Mayas and Aztecs, vanilla was a key ingredient to make the drinks of the gods. Today, it is one of French people's favorite flavors, present in many sweet food products such as yogurts, pastries, or chocolate. But the vanilla bean is a rare ingredient for several reasons. Firstly, due to its access and availability. Vanilla beans, mainly grown in Madagascar, are very fragile due to climate risks and need to be pollinated manually. Secondly, due to its inconstant quality, some producers pick up the vanilla beans too soon, which lessens their quality. And finally, because of the durability of the prices. Prices are constantly rising, around $600 per kilo in 2017. The vanilla taste is mainly due to the presence of an aroma called vanillin, present in vanilla beans. Vanillin is only present in small amounts in the brown bean, between 1% and 1.5% in recent crops. Alternatives therefore had to be found to bring the vanilla taste to consumers by producing vanillin made from other natural materials such as rice bran or synthetic vanillin. Consumers can find this vanillin under different forms. Pure vanilla extract made from 100% vanilla bean, natural vanilla extract made from 95% vanilla bean and 5% other natural ingredients to give it its authenticity, natural vanilla aroma, containing natural vanillin made from rice bran, for example, and finally as a synthetic vanilla aroma, often made from synthetic vanillin. To summarize, the vanilla taste can be brought to consumers under many different forms.
Next is the physical properties for the vanillin. The molecular formula for the vanillin is cis-8H8NO3 and the IUPAC name for the vanillin is 4-hydroxy-3-methoxybenzaldehyde. The molecular weight for the vanillin is 152.15 gram per mole and the density is 1.056 at 68 Fahrenheit. The melting point for the vanillin is at 81 until 83 Celsius and the boiling point is at 285 Celsius. The French point is at 153 Celsius and the vapor pressure is at 107.2 Celsius. The pH for vanillin is acidic and the pKa for the vanillin is 7.4 at 25 Celsius. And the water solubility for the vanillin, it is a slightly soluble, and the appearance for the vanillin is a white crystalline solid. That's all for the properties of vanillin. Thank you. Next is the chemical properties for the vanillin. It is divided by 4. Firstly is the odor or the smell. Secondly is the color. Thirdly is the miscibility, and lastly is volatility. The smell of the vanillin, it has a vanilla smell. It smells sweet, pleasant, and balsamy. The color of the vanillin is white, off-white, or sometimes it is yellow. In the temperature room, the vanillin become the hygroscopic powder. For the miscibility of the vanillin, the pure vanillin has a low solubility in the cold water, which limit its process or application in the aqueous base. For the volatility, the vanillin is a fairly volatile compound and has a low saturation vapor pressure. That's all for the chemical properties for the vanillin. Thank you.
Aspect about the benefit of vanillin. First, it is for flavoring agent, widely used in food court products to impart a vanillin flavor, enhancing the taste of dessert. Next, aromatic properties. It is employed in the fragrance industry for perfumes, candles, and air freshener due to its pleasant aroma. And lastly, as a mood enhancement, because the aroma of vanillin may have mood-lifting properties, promoting relaxation and reducing stress. Vanillin can be used in cosmetic and personal care. It can be found in lotions, creams, and other personal care. Other than that, it is used in pharmaceuticals, sometimes used as a flavoring agent in medicine to make it more palatable. Lastly, it is used in chemical synthesis, serve as precursor in the synthesis of various chemicals and compounds in organic chemistry.
Alright, the next one is chemical reaction. Synthesis of vanillin. The euglynol undergoes isomerization and form isoeuglenol. Next, it undergoes oxidation, produce product which is vanillin, acetaldehyde and water. Alright, the next chemical reaction is esterification reaction. Vanillin reacted with the acetic acid anhydride under base condition, which is sodium hydroxide, to form monoester by reaction at the phenyl OH group in vanillin. Alright, the last chemical reaction is oxidation reaction. Vanillin undergoes oxidation in presence of the certain oxidizing agent and form the formation of vanillin acid. To conclude our presentation, vanillin is an important compound that is the main component of vanilla flavor and aroma, and it's widely used for food, beverages, cosmetic, and also pharmaceutical industry. Its importance lies not only in its sensory appeal, but also in its antioxidant and antibacterial. Vanillin is produced both naturally and it's synthetically and its key ingredients in various formulations. Ongoing research aims to optimize its production, explore sustainable methods, and it investigate its wider application in health and well-being. Vanillin therefore remains its valuable compound with versatile uses and its promising future. That's all from us. Thank you.
This is the citation. That's all from us. Thank you for watching.